Alright, welcome to 1-2, day 1 notes. So the first thing we're going to look at is what does it mean that our data is univariate as opposed to bivariate. So we're looking at number 13 there. Univariate involves one variable, which you probably were able to figure out, while bivariate involves two. Alright, so when we're examining univariate data, we are going to use this acronym called SOX. So this is something that you'll definitely want to be very familiar with. We'll use it throughout the entire year. So the S in SOX means shape. The first S in SOX means shape. So there's a few different types of shapes that we look at. There's symmetric. Oops. Try that again. Which kind of is that bell curve. You have to be careful when you identify this because symmetric itself is not enough. So you basically need to say one peaked and the right and left sides of the graph are approximately, so get really familiar with this word because you never use the word exactly or is in stats. Everything's kind of iffy. So approximately mirror images of each other. So if I was going to describe a graph, describe the shape of a graph, I would say it's single peaked and symmetric. And that would be good. This is just the definition, the right and left sides is the definition of the graph. But you do need to say single peaked or one peaked because it could be bimodal and still be symmetric. All right, the other kinds are skewed to the right. So skewed to the right is kind of like where the tail of the data goes. So most of the data is going to be on the left side, and then there's going to be data that's pulling it to the right. So skewed to the right, right? It's where the tail is, skewed to the right. And then skewed to the left is basically just the opposite. So you have a lot of the data on the right side, but something's pulling it out to the left. So you look at the tail. Where the tail of the data is determines the skewness. All right, and then bimodal, sometimes we see this data, we don't really deal with it a whole lot. In stats, it kind of looks like a two-humped camel, there we go. So that's why, you could see that could be symmetric. So that's why you have to say single peaked when you're talking about a symmetric distribution. All right, so next let's look at outliers. So that's what the O in SOX stands for, it's outliers. So there actually is a formula for finding outliers. We'll work with it later, but the formula is Q1, the first quartile, minus 1.5 times the interquartile range, or Q3 plus 1.5 times the interquartile range. And again, we'll worry about that formula a little bit later, but that's how you determine what it is. So an outlier is an individual value that falls outside the overall pattern. and the next thing that we look for is called the center. So the center, when you have a symmetric distribution, single peak symmetric distribution, you're going to use the mean to determine the center. If you have a skewed distribution, you are going to use the median. Right? The reason why is because the mean is more subject to be pulled towards the outliers, whereas the median is more resistant to the outliers, because even if there's just one extra piece of data on the right side of the data, you know what I'm saying? Like if there's a really small number or a really big number, it really doesn't affect the median because it only basically moves the median over like one number or half a number. Whereas the mean, if you had a really big number, it would really increase the mean. All right, and then the next one is spread. So the spread is how much variability there is in the data. So when you use the median for the center, you use the range or the IQR, which again is the interquartile range. And the mean, if possible, if given enough data, you're going to use the standard deviation. Which is the average distance something is from the mean. So we just need to know that for right now, and we'll go from there.